It all begins with the roasting and smelting of nickel, zinc, copper, and lead. These minerals are found naturally in the form of sulfide ores, such as copper sulfide. Following concentration of the mined ores, the first step of metallurgical refining is removal of the sulfur content. Heating the concentrated ore liberates sulfur in the form of sulfur dioxide gas, or SO2. If not captured and removed, SO2 gas can contribute to the formation of acid rain. At Falconbridge smelters, SO2 gas is captured and converted to a valuable product, sulfuric acid. Sulfuric acid production at smelters is the direct result of emission controls designed to protect the environment. Smelter acid plants are comprised of three major stages. The gases are first thoroughly cleaned in the gas cooling and cleaning section. Next, a large blower draws the cleaned gases to the conversion section. And finally, the absorption stage, where the sulfuric acid is actually produced. The first stage, gas cleaning, is a critical step. The gases produced from smelters can be varied and complex. At a smelter such as the Horn, one of the major features is the level of efficiency required to cool and clean the gases that feed it. This section often draws on highly sophisticated technology. The alloys used have undergone multiple corrosion tests. Smelter off-gases at the Horn enter the quench tower at about 350 degrees Celsius, where the temperature is lowered to 80 degrees by water saturation and evaporative cooling. The fine metallic particles entrained in the gases are then amalgamated in the retention tower. Next, the gases go to the Venturi scrubber, where the amalgamated metallic particles combine with droplets of weak acid, which was introduced through powerful sprays. Most of these droplets settle to the bottom of the vessel. The remainder flows out of the vessel in the form of a fine mist intermingled with the sulfuric gases. The Venturi scrubber design enables varying the pressure drop across the unit in order to assure its effectiveness in cleaning the gases efficiently under diverse operating conditions. After leaving the Venturi scrubber, the gas and mist are drawn across 5 parallel lines of 2 condensers and 2 precipitators each. The condensers reduce the amount of moisture in the gases and condense the residual metallic vapors prior to their entering the mist precipitators. Each precipitator unit contains 243 lead tubes, which use electrostatic charges to capture nearly all of the condensed fine droplets and acid mists still present in the gases. As a result, the impurities are separated from the sulfur dioxide gas as they are carried off in the weak acid. The impurity-laden weak acid is pumped to the effluent treatment plant. At the Horn, mist precipitators complete the gas cleaning, enabling an estimated 99.99% removal efficiency for most of the impurities present. The Horn's 10-paired precipitator units are one of the largest installations of this type in North America. Minute quantities of mercury vapor, which might be present in the gases, are recovered in the 2 mercury towers before the gases are introduced into the drying tower. The dry gases, free of mist and impurities, then enter the second section of the plant through the massive centrifugal blower. The blower, with its 12,000 horsepower motor, is one of the largest units in North America. From here, the gases move to the third and final stage of the process, conversion and absorption. One of the most critical steps in the sulfuric acid production process is the oxidation of sulfur dioxide to sulfur trioxide. Sulfur dioxide-rich gases enter the catalytic converter to be converted in successive stages to sulfur trioxide. The elevated temperatures generated by this reaction are controlled by a series of heat exchangers. The Horn acid plant incorporates one of the world's largest converters, equipped with an internal heat exchanger. After their conversion, the gases are driven to the base of the absorption tower, where the sulfur